Hello, in this video we will go over 7 examples involving separable differential equations. We will um, we will do examples involving initial conditions and finding the interval of validity. So you probably learned about separable differential equation in calculus 2. If you did, that's good. You're just going to need some integration techniques. So we will review that. So yeah, separable differential equation uh, can look like this: dy dx equals gx times h of y. It'll also look like this. It can also look like this, and it can also look like this. So just remember this: for a separable differential equation, you can only cross multiply. If you can't, then it's another technique. So let's let's kind of review the steps for a separable differential equation. So step 1, separate or cross multiply only. Step 2, once you have both the y's and the x's on one side, integrate both sides and place constant of integration on the right-hand side implicit solution. If you're giving an initial value problem, like a coordinate or initial condition, plug it into the implicit solution and solve for the arbitrary constant. Solve for y equals f of x, explicit solution if possible. Step 5, if given initial value problem, provide the interval of validity, largest interval where the function is continuous, differentiable and continuous, differential and contains the IC initial condition. So let's do example 1. So example 1 says find a 1 parameter family solutions for each equation, and we are not given an initial condition. So step 1, so we have dy over dx equals y times sine of 5x. So step 1, I would separate. Or cross multiply. Okay, so that's what I'm going to do. This has a denominator 1. Go ahead and cross multiply. 1 times dy. 1 times dy is dy. This whole thing, y sine of 5x times dx is itself. Then what you want to do is get all the y's and all the x's on one side. So maybe I can get rid of this y, move it on the other side. So to do so, I'm going to divide both sides by y. And that canceled. And then over here, this is good because this is a sine 5x. So that's x, so that's good. So on the left side, dy over y can also be expressed as 1 over y dy. Over here, it's just sin of 5x, or you can say parentheses 5x dx. Okay. So now that we have all the y's and all the x's on one side, step 2 is integrate. Go ahead and integrate. So left and right. So it's going to be integration of 1 over y dy. This is the integration of sin of 5x dx. Okay. So over here, what is the integration of 1 over y dy? It is the ln of absolute value of y. Over here, how do you integrate sine of 5x dx? Yes, you have to do u substitution. So my u would be 5x, and my du would be 5 dx. Now we have to get rid of this constant 5 because we don't have a 5 here. So how to get rid of this 5? By multiplying both sides by the reciprocal of 5, which is 1/5. Right? So this is 1/5 du. 5 times 1/5. The 5's cancel, so you're just left with dx. So it's going to be the integration of sin of u, and then you're going to replace dx with 1/5 du. Okay. Now 1/5 is a constant, so you could just put that in front of the integration. Okay. So what is the integration of sin of u? It is negative cosine of u. And then you still have this 1/5. If you put it all together, this is going to be negative 1/5 cosine. And then you may replace u with 5x. And then I think, yeah, we could put the plus c on the right-hand side. So put a plus c here. And then on the left side, you're left with the ln of absolute value of y. So this right here is called this right here is called the implicit solution, right? So let's try to get the explicit. Can we? So what is the explicit solution? It's basically when you get y by itself. So can we, sometimes it's not possible, sometimes it is. Can we get y by itself? I think we can. What would you have to do? Well, you have an ln, so there's a good choice. To get rid of this ln, you have to take the e, raise everything to the e. So go ahead and raise everything to the e, so it's going to be e ln of absolute value y equals e to the negative 1/5 cosine of 5x plus c. Okay. Now over here, what is e and ln? They cancel. And the absolute value y is positive y, so you could say y equals e to the negative 1/5 cosine of 5x plus c. Can we simplify this? I think you can, right? Remember when you're multiplying with the same base, you're adding, for example, an times am is equal to an plus m. Or you could think of it like as x3 times x2 is the same thing as x5. So when you're multiplying with the same base, you're adding. So I guess you can break this into two separate e. So you can, this part right here could be written as e to the negative 1/5 cosine of 5x times e to the c. And e to the c is a constant, right? It's a number raised to a constant is a constant. So you can say that could just be c, and then you could put that in front of the e. So that would be c e to the negative 1/5 cosine 5x. So yeah, here is your explicit solution for a one parameter family. Okay, here's your final answer. Okay, let's move on. Let's move on to example 2. So example 2 says, find a one parameter family of solution for each equation, and there is no problem because I did not write it. The problem is this. ln of y dy over x dx. And then over here, this is going to be x plus 1 over y square, right? So yeah, let's do this one. So is there anything we can simplify before we move on, before we cross multiply? I think we could simplify the right side, right? X plus 1 over y, all in parentheses squared, is equivalent to saying you can write it as two separate fractions. So the top fraction would be parentheses x plus 1 square, and then on the bottom, y square is y square. And then on the left, I think you could just leave it as it is. Okay, then what you would do is go ahead and cross multiply, or get all the x's and y's by itself. Okay, so this is x times x plus 1 square dx, and then this is going to be y square ln y dy, right? Now we're lucky. We have all the x's and all the y's on one side, so we don't have to like still move things around. Now, we guess we can integrate, right? Wait, right here, can we before we integrate, can we simplify this? Yes. X plus 1 square is the same thing as x plus 1 times x plus 1. And then you have this extra x. What happens when you FOIL it out? You should get x cubed plus 2x squared plus x, and then you have this dx, right? Now, what about the right side? So you have the integration of y squared ln of y dy, right? Okay, this one is easy. You just use the power rule, so that would be the integration of x cubed is 1/4 x to the 4th. The integration of 2x squared is 2/3 x cubed. The integration of x is 1/2 x squared. Now, what about the right side? So also, I'm going to put the plus on the left. You could also put it on the right. It doesn't really matter. I'm just going to put it on the left for this problem. And then over here, how do we take the integration of y squared ln of y dy? Well, you can't do use substitution, right? They're multiplying two products. So when you're multiplying two products, you're going to have to use the integration by parts, right? So when you have two multiples of an integral, you're going to most likely do integrating by parts. But late. So it's like a little riddle that you do for it's like a little riddle to figure out which one you would do first. So the I stands for inverse. You don't have any. The L stands for log. The A stands for algebra. The T stands for trig. And the E stands for exponential. Okay. So what do we do? So what is integration by parts? It's this. It's u v minus integration of v du, right? That is the integration of parts. So what do you think our u should be, and what do you think our v and our dv and our du? So I believe our u is going to be ln of y, and the derivative du, what's the derivative of ln of y? It's 1 over y dy. And then my v, or my dv, is the more simpler one, so that would be the y square dy. And the v is the integration of dv, which is the integration of y square dy. So v is going to be 1/3 y cubed. Okay, so let's continue putting it in this formula, uv minus the integration of v du. So u is ln of y times v is 1/3 y cubed minus the integration of v du. V is 1/3 y cubed times it by du, which is 1 over y dy. Okay, and I guess if you kind of clean this up, over here, I guess you could put that 1/3 first, so that it would be 1/3 y cubed ln of y minus over here. I guess you can simplify this. This 1/3 is a constant, so you put that in front. And then what's y cubed times 1 over y? It's just y squared dy. Okay. And then we know that the integration of y2 is pretty simple. It's 1/3 y cubed, and then you still have this negative 1/3, which is negative 1/9 y cubed. Here you have 1/3 y cubed ln of y minus 1/9 y cubed, and then on the right side it was the left side, so you can switch the orders around. So on the right side it is going to be 1/4 x4. Now, this would be your implicit solution, right? We don't have an initial condition, so this is my implicit. Now, can we put it in explicit? I don't think so. I don't think we can actually solve for y. It would be nearly impossible. So yeah, we cannot. I don't think we cannot put it. Cannot put it into explicit. Okay, let's move on. Sample 3. So example 3 says, find a 1 per meter family of solutions for each equation. And we do not have an initial condition. So we have dy over dx equals xy plus 3x minus y minus 3 all over xy minus 2x. Look at that problem. Before you cross multiply, is there anything you can do? Just go ahead and take a second and look at it. Yeah, if you look at the right side, you can factor, right? On the top, you can fact there's exactly four terms, so you can try factoring by grouping. On the right, on the bottom, you can just factor out an x, right? So let's look at the top right here. We have xy plus 3x minus y minus 3. Let's try to factor this by grouping because there's four terms. So split it into two parts. On this part, xy plus 3x, it looks like you can take out an x. So that's going to be y plus 3. Over here, negative y minus 3, it looks like you could take out or factor out a negative 1. And it does work. Why does it work? Is because you see the repeat, y plus 3, y plus 3. If you have a repeat, then it works. So you just write out the repeat once, and then bring down your leftover. Your leftover is x and negative 1. Okay, so on the top, that's what it gets factored, and then on the bottom, we can looks like we could take out 1x. So this is y minus 2. And then on the left, it's dy over dx. Okay, what would I do next? I would now cross multiply. So step one, cross multiply, or get all the x and y's by itself. So go ahead and cross multiply. This is going to be x parentheses 1 minus 2 dy. For here, this is going to be y plus 3 x minus 1 dx. And then what I would do next is before I take the integration, I have to get all the x's on all the y's on one side. So what can I do? Maybe get rid of this x. So I'm going to divide both sides by x. This cancels, and then we're left with 1 this 2y. And then over here, this is an x, by the way. What else can I do? I should get rid of this y plus 3 because it has a y. So I'm going to multiply both sides by the reciprocal of that, which is 1 over y plus 3. Okay, so this cancels, so we're left with x minus 1 over x dx. For here, it's just going to be y minus 2 over y plus 3 dy. Okay, now you can take the integration of both sides. Okay, on the left side, how do we take the integration of y minus 2 over y minus 3? Yes, you said it. You would have to use substitution. And then over here, uh, it's a fraction, right? I guess you can simplify this more, right? If you divide each term by x, x over x is 1 minus 1 over x, and then you have this dx. Okay, what would I do next? So let's do the left side. I think the left side would be easier. Um, I'm going to do use substitution, and I think I'll use wait, before I do use substitution, I think I would have to do long division or synthetic. Yeah, I would do first use long division. over synthetic division. Let's do that. Let's do long division. And I'll think I'll just use 1. So 1 times y is y. 1 times 3 is 3. Distribute this minus. And this cancels. This is -3 minus 2 is -5. So you get 1 plus -5 over whatever your remainder is, whatever you're dividing. So -5 is a remainder, and then you divide it by whatever you're dividing. You get integration of 1 plus -5 over y plus 3 dy. And then what about here? How do I take the integration of 1? You could just take, yeah, you could just take the integration of each term. So what is the integration of 1x? What is the integration of, so I'm basically taking the integration of each term. What is the integration of 1 over x? ln of x, or ln of absolute value x, but you have a minus in the middle, so it's going to be minus ln of absolute value of x, and then you could put the plus c on the right. Okay, what about here? We have 1 plus -5 over y plus 3 dy. They're two terms, so this one's easy. What is the integration of 1 in respect to y? It would be y. What about this? How do I take the integration of -5 over y plus 3 dy? The only way you would do this is use u substitution. And your u would be y plus 3. And then if you take the du, this would be 1 dy. Yeah, maybe we should get rid of this -5 as a constant, so maybe bring that down. And then it's just 1 over y plus 3 dy, because that's much easier. And that's 1 over u, and then our du is 1 dy, so we don't have to cancel anything or get rid of this. You just replace dy with du. And what is the integration of 1 over u? Yes, it's the ln of absolute value of u. And then you still have this -5. So the left side will now be y minus 5 ln, and then the absolute value of u is y plus 3. Equals, and then on the right it was x minus ln of absolute value of x plus c. And this is your implicit. There's implicit, and I don't think you can do explicit. It would be nearly impossible. So yeah, this is our implicit solution. Okay, let's move on to the next one. Example 4 says find a one parameter family a solution, and I did not write the problem. It says find a one parameter family solutions for each equation, and our problem is dy dx equals to 6y squared x over 1. And they actually give you an initial condition. Our initial condition is y1 equals 1 over 25, right? So you could think of this as a coordinate if you like. 1 is your x, your y is 1 over 25, right? Okay. First step is cross multiply. So 1 times, 1 times dy is dy. This whole thing is 6y squared x and then dx. Let's see, got to get all the y's and all the x's on one side, so maybe get rid of this, move this y squared to the left by dividing both sides by y squared, right? Okay, so you get 1 over y squared dy equals 6x dx, right? And can we take the integration? Yes. Yeah, I think these are pretty simple, right? What's the integration of 1 over y squared dy? Be careful, it's not 1 over y, it's 1 over y squared dy. Maybe I can rewrite this as a negative power. 1 over y squared could be expressed as y to the negative 2 dy. And then this one's easy. What's the integration of 6x? It is 6x squared over 2. So that is 3x squared, and then don't forget the plus c. What about here? What is the integration of y to the negative 2? So negative 2 plus 1 is negative 1. So that's y to the negative 1 over negative 1. So y to the negative 1 is 1 over y. And then you still have this minus. Okay, now we have to plug in our initial condition because we got to find the c value, right? Our initial condition is an x coordinate of 1 and a y coordinate of 1 over 25. It's negative 1 over, and then replace y with 1 over 25. And then this is x is 1 squared plus c. So on the right, 1 squared is 1 times 3, that's 3 plus c. And then what's negative 1 over 25? I'm not sure. You just have to plus 1 plus negative 25 over 1. And then go ahead and plus solve for c. So I would have to subtract 3. Subtract 3, I get c equals negative 28. Okay, so we can rewrite it as so on the left, the integration of y to the negative 1 is negative 1 over y. And then on the right side of the equation, it was the integration of 3x, 6x is 3x squared. And then the plus c, and we just found the c was negative 28. Okay, go ahead and cross multiply. So 1 times negative 1 is negative. What do we do? We're trying to solve for y, right? Because we can solve for y. It's not too bad. 1 times negative 1 is negative 1. Y times that, that's 3x squared minus 28. So I want to solve for y. Got to get rid of this. How do I do that? Divide it by itself. Cancels, and then now you're left with y equals negative 1 over 3x squared minus 28. Now, you see how there's a minus here and a minus there? You can factor out a minus, right? And then if you do that, and if you do more adjusting, it'll give you y equals 1 over 28 minus 3x squared. Um, yeah. So, okay, so this is your explicit solution. Now, we kind of, this time we do have to find the domain because we have to find the interval of validity, right? So what kind of graph is this? 1 over 28 minus 3x squared. What kind of graph that is? Uh, that is a, what is it? When it's an fraction, rational function, right? And then how do you find the domain of a rational function? You basically set the bottom to 0 and solve for x. So if you do that, set the bottom to 0, 28 minus 3x squared, set that to 0, and then if you actually solve for x, so you would have to like subtract 28, divide this by -3, and I get positive 28 over 3. And you get, and then you got to solve for x, so you got to take the square root of both sides. So you get x equals plus or minus square root of 28 over 3. So you have two x values. You can have positive square root of 28 over 3, and then you can also use negative square root of 28 over 3. Okay, so that's how, so what that means is the domain is, if you write it as an interval notation, it can be written as negative infinity, comma, negative square root of 28 over 3, union minus square root of 28 over 3, comma, positive square root of 28 over 3, union, and then positive square root of 28 over 3, comma, infinity. So basically, all real numbers except x cannot equal this value and this value. So what would be our interval of validity? So the interval of validity is where the graph is at. So it's basically at here, negative square root of 28 over 3 to positive 28 square root of 3. So your interval of validity would be from negative square root of 28 over 3, comma, square root of 28 over 3. Okay, let's move on to example 5. So example 5 says find a one parameter family solution for each equation. We have y prime equals 3x squared plus 4x minus 4 over 2y minus 4. And we have an initial condition of y1 equals 3. So what can I do? On the left side, we have y prime. We know y prime can also be expressed as dy over dx. Okay. The next step I would do is cross multiply. So go ahead and cross multiply. So it would be 2y minus 4 times dy. And then on the right, it's going to be 3x squared plus 4 times by dx. Okay, I think we're lucky. We have all the x and y's on one side. So all we got to do is just start taking the integration. This is integration of 2y minus 4 dy equals the integration of 3x squared plus 4x minus 4 dx. Oops. Okay. This one's not too bad. How do you take the integration of 2y? It's just 2y, this has power 1, so 1 plus 1 is 2, over 2. And then the integration of negative 4 is negative 4y. Kind of clean this up, the 2's cancel, so we're left with y squared minus 4y. These ones are not too bad as well. It's just use the power rule, right? So the integration of 3x squared is 3x, 2 plus 1 is 3, over 3, plus the integration of 4x1 is 4x, 1 plus 1 is 2, over 2, minus 4x. And then I guess you could put the plus c on the right. Okay, so on the left you have y squared minus 4y equals, here you can kind of clean this up, right? This 3 is canceled, so we're left with x cubed plus 4 over 2 is 2 minus 4x plus c. Now, the next step I would do is solve for my y. You give us an initial condition of y1 equals 3, or you have an x coordinate of 1 and a y coordinate of 3. Go ahead and plug that back in here. So my y is 3, so it's going to be 3 squared minus 4 times 3 equals 1 cubed plus 2 times 1 squared minus 4 times 1. See? 3 squared is 9 minus 12, and then 1 cubed is 1 plus 1 squared is 1 times by 2, that's 2, negative 4 plus c. Okay, 9 minus 12 is negative 3. 1 plus 2 plus negative 4 is negative 1. Right? 1 plus 2 is 3, plus negative 4 is negative 1. Solve for c, so I'm going to add 1, and then negative 3 plus 1 is negative 2. So my c is negative 2. Now, you can put it in explicit. So, let's see. On the left, it was y squared minus 4y. And then on the right, it was x cubed plus 2x squared minus 4x minus 2, and then the plus c, which is negative 2. Did I put an extra 2 somewhere? I think I did. Yeah, I put an extra 2. That this should be this. Now, this is your implicit form. Can we get it in explicit form? I think we can. We would probably have to do quadratic formula. And what I would do is when you're doing it in a quadratic formula, we could do quadratic and we have to get one side 0. So what I would do is like move everything to the left. So get all this to the left. So you would have to subtract. So you would get all this by subtracting it. So it'd be y squared minus 4y minus parentheses x cubed plus 2x squared minus 4x minus 2 equals to 0. And what would I do next is so this y square or this 1 is like your a, your b is this -4, your c is this whole thing. So if you recall, the quadratic formula is y equals opposite of b plus or minus root b squared minus 4ac all over 2a. So that's y equals opposite of b, which is +4 plus or minus root b squared is, our b is -4, so it's -4 squared minus 4 times a, which is 1, and our c is x cubed plus 2x squared minus 4x minus 2 all over 2 times a, which is 1. So it's y equals 4 plus or minus root. -4 squared is 24. And then if you kind of clean this up and FOIL it out, you should get plus 16x minus 8x squared minus 4x cubed all over 2. So this would be your explicit, which this time we could have solved. So what would be the interval of validity? Uh, so the interval of validity is basically this whole thing where it's greater than equal to 0, right? So yeah, let me write that. Your interval of validity is this whole thing. That greater than equal to 0. And I tried grouping by factoring will not work, so it's just this. Yeah. Okay, let's move on to example 6. So example 6 says find a 1 parameter family solution for each equation. We have t times dy over dt equals y, where an initial condition of y1 equals e. Okay, so what would I do first? Yes, so wait, you can rewrite this as t dy over dt equals to y over 1. So what would I do first is cross multiply. So this would be 1 times that, that's t dy. Over here, this is going to be y dt. It looks like I'm going to have to move things around. Move this y to the left by dividing both sides by y. We get t dy over y. And then over here, you're just left with dt. Then what I would do next is, what would I do next? Get rid of this t, because you want to get all the t's on one side by multiplying both sides by 1 over t. Okay, so this cancels. So you're left with 1 over y dy, and then on the right, it's 1 over t dt, right? Okay. Now go ahead and take the integration, both sides. Okay. So the integration of 1 over y is simple. It's the ln of absolute value of y. And then the integration of 1 over t is the ln of absolute value of t, and then plus c. Now go ahead and solve for c because we have an initial condition. Our initial condition is 1 comma e. 1 is your x, y is your e. So it's going to be ln of absolute value of e equals ln of absolute value of t, which is 1 plus c. And the ln of 1 is, I believe it's 0. And then the ln of e, or the ln of absolute value v, is just ln of e. That just becomes 1. So your c is 1. So now we have, if you go back, it's going to be ln of absolute value y equals ln of absolute value of t, and then plus your c value, which is 1. Can we put it in explicit? So this is implicit, right? This whole thing is implicit. Can we try to put it in explicit? I think we can because they both have an ln. So that's a big clue. You could just take the e on both sides. So this is going to be e ln of absolute value of y. This is going to be e ln of absolute value of t plus 1, right? And then on the right side, you can simplify this because you have plus 1 here, so that could be expressed as e ln of absolute value of t times e to the 1. Okay, and then over here, the e and the ln cancels, and you're left with y. Over here, the e and ln cancels. So your final answer is y equals absolute value of t, and then e to the 1 is a constant, so you could put that in front. And that would be your final answer. So this would be your final explicit answer. If you're curious about the interval of, if you're curious about the interval of validity, what does this graph? So interval. This is, what kind of graph is this? This is an absolute value times by a constant. So that would look something like this. Right? It starts at your vertex is 0, 0. So it's not differentiable. On the cusp, right? You can't take the derivative on a cusp. So it's continuous and differentiable from negative infinity to 0, union 0 to infinity. So the interval of validity is from 0 to infinity. Okay. Okay, let's do one more example. And then we can end it here. Okay, so example 7, find a one parameter family solution for each equation. dy over dx equals parentheses 1 minus 3 squared with no initial condition. So the first step is cross multiply. Here, this would be, okay. Now, do we have all the y's on all the x's? So no, what I would have to do is probably like get rid of this or move it on the other side by dividing it by both sides. Like so. This cancels, so you're left with dx And then over here, you're left with 1. Okay, now you may take the integration of both sides. So oops, this is going to be the integration of 1 over y minus 3 squared dy, and then the integration of, this is like a 1, so it's the integration of 1 dx. Simple. The integration of 1 dx is just x. What about here? How do you take the integration of 1 over parentheses 1 y minus 3 square? You would have to do u substitution. So your u would be y minus 3, and then my du would be 1 dy, which is really nice. So you're going to rewrite this problem as 1 over y squared dy, and then on the right, it's x, and then don't forget the plus c. The integration of 1 over y squared, you can rewrite that as 1 over u to the negative 2 dy. And the integration of u to the negative 2 is negative 1 u to the negative 1. So that's negative 1 over u equals x plus c, and negative 1 over u. What is our u? We said our u was y minus 3. Equals x plus c. So 1, and then cross multiply. 1 times negative 1 is negative 1. And then this is going to be y minus 3 times x plus c. And you want to try to solve for y, so get rid of this x plus c by dividing both sides by x plus c. Cancels, you're left with y minus 3. And here it's negative 1 over x plus c. And then, oh, then just get y by itself. So you would have to add 3 to both sides, add 3 to both sides. So you get y equals 3 minus 1 over x plus c. And that's it. That is the last example of separable differential equations. So we will stop here.